Okay, so for this video, I'm gonna prepare you for the midterm exam for mce180, and the place to start for that would be in the study guides folder of the Google Drive, and you're going to click on study guide number 01 for the midterm, and here's the solution to that, and here's the start file. Okay, so if you open this file, you're gonna get this, and it's got different tabs. Okay, it starts with a cover page. It's got different exercises that you gotta do, and I'm gonna go over this study guide. Now, this was an old exam of mine. Your exam is gonna look a little different when you come to class. The time that we meet and you're ready to take this midterm, this me01 is gonna show up. So again, this number, this exam is only gonna show up as soon as class starts. So for example, in this semester, it's spring 2020. We meet at 4 to 5:50 once a week. So at 4 p.m. this is going to show up. It's never going to show before that. It's going to show at 4 p.m. or later. So it starts at 4 p.m. and then it's going to end at the time the class finishes, which was 5:50 p.m. for that semester. So after 5:50 p.m., the late penalty algorithm kicks in at 3% per minute. So that means if you're 3 minutes late, it's going to deduct 9%, one letter grade. So it's very important that you submit on time. So when you click on the exam, let's take a look at what you're going to see. Alright, what you're going to get are 3 slabs. Alright, it's very simple. One is going to be like your homework 1, which was draw an orthographic. Another one is going to be like homework 2, draw your isometric. And then the third one is going to be dimensioning, so just like homework 3. In homework 3, you had 15 multiple choice questions. On this one, you're going to have 10. So these two are going to be much more simple than your homework. So for example, if we go to homework 1, let's take a look at homework 1. Okay, if you click on this button, you were asked to draw orthographic views. This is somewhat complicated. Not terribly complicated, but somewhat complicated. For the exam, you can you can think of something similar to this, only half the complexity. So imagine something that is half as complicated as this. Same with the second tab for the isometric. Okay? So it should be a very straightforward exam. Very straightforward. I don't think it should be too difficult. Okay, most students finish within 30 minutes. So it shouldn't take you too long. But I'll give you the whole hour and 50 minutes to, double check and whatever. But most students usually finish within 30 to 45 minutes. So overall, I don't think this is a really difficult exam relative to the other ones. This is really just to get you started before we start getting into the SolidWorks portion of the class. But anyhow, that's how this is going to be set up. Okay, so three examiners, 1, 2, 3. So what I'm gonna do now is do a similar exam. See, as you can see, there's the 3 tabs, and I'm just going to practice with this interface. Okay, so I'm just gonna turn on my layers. They're right here. I'm just gonna start with a solid layer, and what you essentially have to do is to draw the orthographic projections of this, and you start with a ref point. Also, before you forget, you might want to update the template. Okay, so make sure to fill all this. There it is. So I'm gonna start drawing. Okay, you're gonna count the cubes. 1, 2, 3, 4, 5. Okay, 5, 3. Alright, so I'm just drawing the projection. Okay, and that's what you're gonna do on the Oswald. Like I'll give you an isometric and draw the projections. Okay, so there's that. Then I'm gonna add a little cube on the top. Okay, remember to hit escape to get out of there. So again, it's always good to start with the visible lines. This is supposed to be halfway. Okay, as you can see here, it's halfway. Then I'm gonna work on the side view. Remember to keep one cube, just to stay consistent. Okay, so let's say we were going to go on this homework one. Alright, and we click on this. Every cube in this class is a 10 by 10 by 10 cube. It means the front view is going to go here. It's going to be exactly one cube in between. Top view is going to go here. Side view is going to go there. So don't deviate from that, because otherwise the grading algorithm is going to get all messed up. So we're going to try to stay consistent with that. So now I'm doing the side view. It's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's going to be 2 here. And there. And then there's some sort of L shape here. And it's going to look like this. Okay. Now let's try the top view. And I'm going to just draw the platform. If you want to use that projection technique, okay, it's up to you. So again, a lot of this is about understanding how the lines correlate. Because again, like I've mentioned multiple times, when we learn how to use SolidWorks, all of this is going to be done automatically, but we got to understand how these lines correlate. So this is why we're doing it like this. Okay. Then there's some sort of roof here, and it's a 2 by 2, as you can see. And that looks pretty good. So that's pretty much all the visible lines, okay, for this exercise. Now we're going to look into some of the hidden lines and center lines. Just going to clean this up a bit. Okay, that's good. Alright, so let's see here. Why don't we work on the hidden lines now? Alright, well, as you can see, this is a through a hole, as shown here, and this is gonna go all the way through, just like that. And that's gonna transfer over there as well. Okay, so why don't I trim the excess? Just like that. That's what I like about the power trim. It's a lot less clicking than some of the other tools out there. Then let's see, where else do we need a hidden line? Well, we need one for this. For a fillet, usually you don't put one, but for a chamfer, you do include a hidden line. And then there's going to be one right through here because there's missing material in the back. Okay, let's see. That looks pretty good. Let me see if I can... Okay, I just added a tangent relation, make it a little cleaner. Okay, we got the hidden line there, there. I believe there's one more missing. See this roof? There's missing material in the back here, so make sure not to miss that. Finally, I'm going to add my center lines. And we're just going to... on the exam, make sure it's one cube past, okay? I'm not doing that here because in a drawing, usually it should only be 1/8 out, something like this, but for the grading algorithm, okay, remember, if you have a circle, you are going to draw one cube, just like that. Okay, so remember, whenever you have one center line, usually you need one on the two other views. So one here, one here, something like that. Alright, we're going to take a look at this and give it a minute and see if we missed anything. I would encourage you to put a center line here as well. Just for this class, okay? In the industry, for a small fillet like that, usually you probably wouldn't need a center line, but for this class, the grading algorithm is going to look for a center line on every circular feature. Okay, so technically you do need one there, but realistically you probably would not need to do that. But for consistency reasons, we're gonna stick to that. So if you see a fillet here, I want to see a center line. Okay, anything that's rounded, half pipes, quarter pipes, full circles, it needs a center line. That's the point of this line, is to say this is a circular feature. Okay, moving on to the second exercise. So now we are given orthographic views and we have to draw, what do you call it, an isometric. So you don't need hidden lines for this, you don't need center lines, all you need is visible lines. So again, we start at the ref point and it's going to go 1, 2, 3, 4, 5, 6. Okay, so 6. See, I even made it easy for you. Like if you go back to the submission page, you see how like it counts you that number, that 8? Yeah, I'll show you. See how like it gives you that number? That makes it easier for you to count lines. That was actually, I had to use the Pythagorean theorem for that. Okay, I had to round the distance between what it's snapping to, so I wanted to make it easy for you. Okay, so alright, so we're gonna go to 1, 2, 1, 2. Okay, line 1, 1, 2, 3. And then 1, 2, 3. 1, 2, 3. Okay, so first do the easy stuff. Okay, so do the easy stuff and then the hard stuff is gonna come later. Okay, we got some. We don't know what this is. We think it's a staircase. We think it's an incline. We don't know. But when we look in the side view, we can clearly see it's an incline. So the way to do that is to count 1, 2, 3, 4, and 1. Okay, so 1, 2, 3, 4, and 1. Just like that. And this connects with this and that. And this goes all the way through there. Alright, we need to create an ellipse. I'm going to see if I can do it with the ellipse tool. It's a little bit tricky. Ooh, okay. Wonder if I can. It's kind of hard. Well, let me see here. It's got to be at an angle like this. Alright, that looks pretty good. I got kind of lucky there. Yeah, I got really lucky. Usually I don't do it like this. I use the 3-point arc tool. Just like this. And I use tangents. I set tangents. Oh, I'm not sure why it's not. Tangents. There we are. So it just makes it a little bit easier to implement. So I hope you see what I'm doing here. The center is here. This is the center. I gotta go 1 across, so it means the boundary is gonna be inside that box. Okay, so again, a lot of this is repetition. We've already gone over all these things. This is just a study guide to prepare you for the exam. Okay, there it is. Okay, let's see here. Yeah, it looks pretty good. Maybe I want to add a line. And maybe I want to make this tangent. Let's see if that does. I'll tell you what. Ooh, see, it's jumping around because my construction lines are getting deleted. So I'm just gonna fix the lines that I don't need. Yeah, that's much better. Again, this is really just to replace the hand sketching portion of the class. I'm going to delete my face because that's messing me up. My goal is not to use this as like a CAD program. Okay, I'm just using this to replace the drafting portion just because it's a little cleaner. Okay, let's see if I can make these two parallel. Alright, that's a little better. Okay, so I'm just gonna move this there. See, it's probably because I didn't use my 3-point arc tool. That's why I don't like using it, because I get all this weird stuff when you use the ellipse tool. Alright, I actually went ahead and redid this using the 3-point arc tool. It just made things a lot easier for me. Alright, I'm just gonna use the power trim to remove this excess. Alright, let's see what else we got going on. We got some sort of through hole here, so... Oh my gosh, I'm gonna use this tool again. Alright, well here's the center of it, okay? You gotta go at an angle. I don't know why I'm using this tool again, it's just so convenient. And it does that. But since this is only 1 cube thick, I need to add a residual here for the back. And that'll be good enough. And also an arc. I'm sorry, a line to show the back. So that's really the idea, okay? Again, you gotta be able to understand where each point correlates. This point is the same as this point, okay, which is the same as that point. You have to be able to, same as this point here. You have to visualize all of those coordinates at any given time, and that's the point of this exercise. Alright, so on the third exercise, you have to dimension this object. So you're given blank projections, you gotta dimension it. So on the midterm exam, you're not gonna have to do that. You're gonna have to just answer multiple choice questions. But on this older exam, this is what they had to do. So I'm going to show you how to do this just for your information. It's good knowledge. Okay, so it starts with a ref point, and then you gotta first define the characteristic view for the features. So these are characterized on the top view. This slot is characterized on the front view, and this L shape is characterized on the side view. So that's where the dimensions are going to go for each. Okay, so again, a characteristic view is where it's best described. Like this is confusing. This is confusing. This slot is confusing here. The slot is only clear here. The counter board is only clear here. That's what I mean by the characteristic view. Alright, from here I'm just going to start adding some dimensions. So there's one. Okay, you just start building, adding the vertical dimensions where it's best characterized, and we're just going to keep doing that, and we're going to go in the horizontal direction now. One there, one there, one here, and one for the overall size. So there's that and that. So remember, we talked about the staggering. This is to avoid confusion. And then we have this. Oops, we have to do this here and this here. Okay, so I'm fully defining the location of these holes and fully defining these ones. You need the X and Y for each of these. Okay, so we're going to add a dimension for the fillet here. And then I'm going to add a dimension for the counter bore. Okay, and then I'm just going to delete what's inside the counter bore. Alright, so if you remember, well, first of all, there's two of these. So I'm going to put 2x, and then we're going to put the diameter symbol. And we're going to put the diameter of the inner hole. I'm going to type through all. Okay, that's the diameter of the inner hole. And then on the second line, we're going to plug in the counterbore symbol. Again, this is all from that slide. If you look at the slide, I spell out what all this means. Then we're going to put diameter symbol, and we're going to put the depth symbol. Okay. So again, the first line is the dimension of the inner hole. The second line is the dimension of the head. Well, you may say, well, where'd you get these numbers from? Well, actually, I went in here and I actually measured it. I went like this. All right, that's 1 inch. That's 2 inches. Okay, and then after I did that, I knew what the sizes were. But again, this is why we use a note for holes, because we don't want the dimension, longitudinal dimension of hole, because it would just crowd the drawing. With just a note that's well understood in the industry, you can communicate a lot of features very easily. Alright, I'm now going to dimension these tapped holes. So again, we're going to go ahead and put a smart dimension here. And let's see here. Let's delete all this. And it's going to be 2 of these, so 2x. diameter. See, we don't know the diameter of this. It says we need a 1/8 hole, so we gotta go to the drill chart. 1/8 hole is right here. It says diameter needs to be 0.875. So we're going to type in 0.875 with a depth of 2.0. Again, I figured that out by dimensioning that view. That's how I knew that number. Okay, so let's see here. Second line is going to be the threads. So we just type in 1-8 UNC, and then we're going to type in the depth symbol, and it's going to be 1.50 MFT because it says minimal full thread required right here. And click OK. That looks good, and we're just going to move that to the side. Okay, top view looks good. Tell you what, I'm going to work on the front view now. So we start at the ref point, and like I said, the slot is characterized here, so that's why I'm going to dimension it there. So I'm going to dimension the location of each of those connections, each of those centers, and then I'm going to add a dimension on that that radii. So there's 2 of these, and it's through. Okay. Uh, 0.5. Okay, that looks good. Sometimes I even put a reference dimension for this. I mean, for this size, it's pretty straightforward, but sometimes I have this weird size, and sometimes I like communicating that just for a slot. Okay, that looks good. Now let me work on the L shape here. So I'm gonna talk about that height. See, I'm keeping the dimensions between the views. That's always good. And 1 here. Alright, let's zoom extents to see what we got. Okay, so now that we have all the dimensions, you may want to just clean things up, make sure everything's well spaced and everything looks good. But what I want to do now is just make sure that there's no missing dimensions. So again, my strategy for that is to pretend I'm trying to machine this. So I need the length, height, and width, and then I need to cut this end out. So my end mill is going to come out here and cut this off. See what I'm trying to do here? I need to know where each of these coordinates are located. That's what I need to know. So I know where it is here. I know I gotta bring my end mill down here, because then this would be this value minus that will tell me how far to go there. So that's essentially what I'm trying to do here. So anyways, I can define that. I need to know this L shape here, so I need the X and Y for that. So that's the overall shape. I also need the fillet, so that's good. Let's cut out the slot here. I gotta bring my end mill up to here, to those locations with that diameter, and this is just reference. So actually I don't even need to select it. These are the dimensions I do need, and I can see that it's going through. Yeah, exactly as spelled out here. Let's see what else. Okay, so we got two tapped holes here. We know the X and Y of each. So we know that these are aligned because the center line is touching. Here we know all kinds of things about the threads, the hole depth, and things like that. Here's the 118 drill bit cut from this drill bit. And then finally we have 2 counterbores, so we need the X and Y of each, and then here we know all the details about this shape. So as you can see, I did not select anything twice. I don't have any duplicate dimensions. I mean, the only one that's duplicate is this, but I didn't really select it. And it's in parentheses, so that's okay. When it's in parentheses, it means it's okay for it to be a duplicate dimension. It's a reference dimension, and it's just used as additional information to add clarity. So there's no missing dimension, there's no duplicate dimension, then I'm ready to save this PDF. So now you can save this as a PDF. Okay. Okay, so then what you have here is the PDF that we created. Okay, so again, there's no PDF on the final exam, but understand that the process is going to be the same. Okay, you're going to draw an orthographic, you're going to draw an isometric, and you're going to submit some multiple choice questions. 1, 2, 3, hit submit, and you're done.